Good morning, students. In the last period, your chapter number 8, Cell Structure and Function, was completed. Today, I am going to start your chapter number 12, Friction. In this chapter, we will learn about force of friction, factors affecting on friction, friction a necessary evil, how to increase and reduce the friction, how wheels are used to reduce the friction. At the last, we will learn about fluid friction. Now, see the chapter. The chapter name is friction. In the Marathi, it is called as Gharshan. Now, see the chapter. You might have seen a driver of a car or a truck slowing down the vehicle at a traffic signal. Now, you might have seen that a bus driver or car driver they slows down their vehicle at a traffic signal. You too slow down your bicycle whenever needed by applying brakes, and you also when you want to reduce your bicycle speed, that time you are applying brakes. Have you ever thought why vehicles slows down when brakes are applied? And that time you thought about that why a vehicle or why your bicycle slows down when brakes are applied. Why this will be happen? Because it is happen due to a force of friction which is present over there between the brake and the wheel of the vehicle. Not only vehicles, any object moving over the surface of another object slows down when no external force is applied on it. Now, it is not only for the vehicles, any object which is moving on the surface of another object. What is mentioned here? Any object which is moving over the surface of another object slows down when no external force is applied on it, and finally it stops. Have you not seen a moving ball on the ground stopping after some time? Now we are aware about that when we are playing cricket, that time when we hit the ball will be moving on the ground, and after some time it will be stopped. It will be stopped by any external force. Now here some questions are there. Why do we slip when we step on a banana peel? Why is it difficult to walk on smooth and wet floor? You will find the answers to such a questions in this chapter. Now this type of question will be arises in our mind. Why do we sleep when we step on the banana peel? This will be happen in our life. Why is it difficult to walk on smooth and wet floor? This type of question will be arises in our mind, and that type of questions answers we will find in this chapter. Now see our next point, force of friction. Force of friction, activity 12.1. And for this activity only two things are required, one table and another one is book. Now see the activity. Gently push a book on the table, which is shown in figure 12.2a. You observe that it stops after moving for some distance. When we push the book gently, it will be cover some distance and it will be stop afterwards. And repeat this activity pushing the book from the opposite direction. Afterwards, what we have to do? We have to push the book from the opposite direction, which is already shown in downside picture. It is shown there. Now, does the book stop this time? Yes, that time also book will be stopped. Can you think of an explanation? Can we say that a force must be acting on the book opposing its motion? Yes. When we are applying the force, that time when we push the book, that time the force it will be act on the book to oppose its motion, and this force is called as a force of friction. Here figure 12.2 a and b. Friction opposes relative motion between the surface of book and the table. Now next, you saw that if you apply the force along the left for this activity, when you do this activity, that time you saw that when you apply the force along from the left direction, friction acts along the right. If you apply the force along the right, the friction acts along the left direction. When you perform this activity, that time what happened? You saw that when you are applying the force on the book from the left direction, the friction acts along from the right direction, and when you apply the force from the right direction, the friction will be acts along from left direction. In both cases, the of the motion force opposes the motion of the book, and in this both the cases, the force opposes motion of the book, and the force of a friction always opposes applied force, and the force of the friction, it always opposes the applied force. In the above activity, the force of a friction acts between the surface of book and the surface of the table. And when we are doing the activity 12.1, in that activity, that force of friction, it acts between the surface of the book and the surface of the table. These are the two contact surfaces are there in this activity. Now, is the friction is same for all the surfaces? Does it depend on the smoothness of the surfaces? Let us find out. Now, another two question will be arises in our mind. Suppose force of friction will be there. Now the force of friction is same for all the surfaces, for rough surface, smooth surface, or it will be depend on the smoothness of the surfaces. We will find out. Our next point, factors affecting friction. Factors which is affecting on friction. Activity 12.2. Now see the activity. Tie a string around a brick. We have to take a string and brick is required. Tie a string around a brick. Pull the brick by the spring balance, which is shown here. See the spring balance. You are already aware about that, the spring balance. Pull the brick by a spring balance, and you need to apply some force, and we have to use it is already mentioned in the figure also, figure 12.3. A brick is being pulled by spring balance, and we have to apply the force on the spring balance to force to pull that brick. You need to apply some force. Note down the reading on the spring balance when the brick just begin to move. It gives you measure of the force of friction between the surface of the brick and the floor. ज्यावेळेस ती वीट त्याची जागा सोडून हलायला चालू करते, त्यावेळेस जे रीडिंग येईल त्या स्प्रिंग बॅलन्स वरती, ते आपण नोट डाऊन करायचं आहे. इट गिव्स यू मेजर of the force of friction between the surface of the brick and the floor, because these two surfaces are contact with each other. Now at the next what we have to do, now wrap a piece of polythene around the brick. In the next activity, what we have to do, we have to wrap a piece of polythene around the brick and repeat the activity. We have to pull the brick which is wrapped with polythene bag by the spring balance. And do you observe any difference in the reading of the spring balance in the above two cases? Yes, there is a difference. In the first, when the brick will be pulled by the spring, that time the force of friction which is measured by the spring balance, it will be high. And in the next activity, when the brick, it is wrapped with piece of polythene bag, in that when we pull, that time the force of friction measured by the spring balance, it will be low related with the first activity. You might be the reason for these differences. And what is the reason for these differences? Reason is that in the first activity, ज्यावेळेस आपण पहिली ऍक्टिव्हिटी करतो, त्यावेळेस जी ब्रिक असते त्याचा रफ सरफेस असतो. वीट जे असते त्याचा रफ सरफेस असतो, आणि ज्यावेळेस आपण ती खेचतो त्यावेळेस त्याचा रफ सरफेस आणि जो खाली जो सरफेस आहे, जो काही प्लेन सरफेस, त्याच्यामध्ये घर्षण जास्त होतं. त्यामुळे काय होतं, फोर्स ऑफ फ्रिक्शन जास्त अप्लाय करावा लागतो. आणि ज्यावेळेस सेकंड ऍक्टिव्हिटी करतो त्यावेळेस काय करतो, आपण पॉलिथिन बॅग यूज करतो, आणि पॉलिथिन बॅगचा सरफेस स्मूथ असतो, त्यामुळे त्यामध्ये अप्लाय करावं लागणार जे फोर्स आहे, जो फोर्स ऑफ फ्रिक्शन आहे, तो कमी येतो. नाउ द नेक्स्ट, रिपीट दिस ऍक्टिव्हिटी बाय रॅपिंग अ पीस ऑफ ज्यूट बॅग around the brick. And what do you observe? And at the last, we have to do the activity wrapping the piece of jute bag around the brick. And what do you observe? When we are when we wrap the jute bag around the brick, and when we are doing this activity, that time also the force of friction will be increases. Why? Because the roughness of the jute bag, it will be increases. Now see, here information is given about the spring balance. Spring balance is a device used for measuring the force acting on the object. Spring balance is a device used for measuring the force acting on the object. It consists a coiled spring which gets stretched when force is applied to it. The spring balance, it is a device to measure the force acting on the object. It consists a coiled spring, which is shown in the figure also. It consists a coiled spring which gets stretched when force is applied to it. Stretching of the spring is measured by a pointer moving on the graduated scale, and the reading on the scale gives the magnitude of the force. Now see the next activity, and very simple activity it is, and you can perform in your home also. Make an inclined plane on a smooth floor. Make a inclined plane on smooth floor or on a table. You may use wooden board supported by bricks or books, and for that inclined plane you can use wooden board also supported by bricks or your books, which is shown in figure 12.4a. Put a mark with a pen at any point A on the inclined plane, and which is inclined plane will be there. On that inclined plane you have to put any point A on that. Now let a pencil cell, remote cell, which cell we are using in the remote. Now let a pencil cell moves down from this point, from the A point. How far does it move on the table before coming to rest? Before coming to rest, it will be take a distance, some distance, and afterwards it will be comes to the rest position, and note down the distance. And we have to note down the distance from the inclined plane to that particular place. And now spread. Afterwards, for the second activity, we have to spread a piece of cloth cover over the table, and make sure that there are no wrinkles on the cloth, and try the activity again. Here you can see the picture. Two students or two boys are performing this activity. Here we have to prepare inclined plane with the wooden board. Table was there. Then afterwards you have to mark point A. From the point A you have to move the pencil cell. You have to release the pencil cell, and whatever distance will be covered by that pencil cell, you have to mark it. You have to measure it. Afterwards, what you have to do? You have to cover the table by the piece of cloth, and make sure that no wrinkles will be observed on that cloth. And afterwards we have to perform this activity again on the cloth. Repeat this activity by spreading a thin layer of sand over the table, and maintain the same slope throughout the activity. Now in this activity also three surfaces we are using. First one only table. Second one, in the second activity we are using cloth, a piece of cloth, and the third activity we are using sand over the table. Now questions are there. In which case the distance covered the minimum? In the third case, when the sand is spread over the table. Why? Because the rough surface. Why is the distance covered by the pencil cell different every time? Try to reason why. Now here one question arises. Why is the distance covered by the pencil cell is different every time, and try to reason why. Now in the first activity, when it is only table will be there, that time it covers more distance, and when we are using cloth, that time it covers the less distance related with the first activity. And the last activity, when we are using a layer of sand, that time it covers very less distance as compared with first and second activity. Now what, why this will be happen? Because because the smoothness of the surface. In the first activity, table which has a smooth surface. Next one, when we are using cloth, it has a rough surface related with the table. And afterwards, when we are spreading the sand on the table, that time also the smoothness will be reduces and roughness will be increases. That's why the distance covered by the pencil cell is different in every time. Now, does the distance covered depend on the nature of the surface on which cell moves? From this activity, one question is asked here. Does the distance covered depend on the nature of the surface on which the cell moves? Yes, it is depends upon the nature of the surface. Could the smoothness of the surface of the cell also affect the distance traveled by it? Yes, it is also depend on the smoothness of the surface of the cell also. Now Bojo, he shall try the activity by the wrapping a piece of sandpaper around the cell, and that time also it get less distance, it covered the less distance because the roughness of the sandpaper. Today up to this we covered, remaining part we will see in the next period.